So on to section 2, we're going to look at transforming and combining random variables. I split this section into 3 videos. One where we will describe the effect of adding and subtracting from a random variable. Then when we actually calculate mean and standard deviation when we are combining random variables. And then when we're looking at, in particular, a normal random variable. So in chapter 2, we did describe the effects of linear transformations on shape, center, and variability of a distribution. So remember, when we add or subtract to the data set, it adds or subtracts from the center, but it doesn't change the variability and it doesn't change the shape. However, when we multiplied, it changed the center, it also changed the spread, but it did not change the shape. So really what we're going to learn in this section is, is there anything different, or is it the same for a random variable? So here we have Pete's Jeep tours that we were introduced to in the first section. Remember, he could hold 2 people, or he would at minimum have 2 people on the tour, and at most 6. And it cost $150 per passenger. So here's just the probability distribution. So if it costs Pete $100 to buy permits, gas, and a ferry pass for each day trip, then V, we're going to say, is his profit. So that means he has to subtract 100 from each of those trips. So instead of it having been $300, it's now $200 because we're talking about profit. So we're taking the original distribution, which we called C, and we're having to subtract 100 from it in order to get our profit distribution. All the probabilities remain the same. It was just the amount that he is gaining from it has changed. So here, let's put them side by side. So we have the total money I've collected, and then we have his profit. So again, written algebraically, V is equal to C minus 100. These are random variables. So how did the distribution shift or change? Well, the center of our profit graph is $462.50. It's just $100 less than the money collected distribution. The standard deviation, well, it's the same because the spread did not change. And then the shape is the same. It did not change. So essentially, it's the same as before. Adding will change the center, but it will not change the variability, and it will not change the shape. So now let's look at the effects of multiplying and dividing. Before, we talked about multiplying, changing the center, changing the variability, but not the shape. So here we have El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units or credits. The number of credits X that a randomly selected El Dorado Community College full-time student is taking in the fall semester is the following. So it's between 12 credits and 18 credits. So we have a histogram of this probability distribution. The mean is 14.65 and the standard deviation is 2.056. So at the college, the tuition for full-time students is $50 per credit. That is, if T is a tuition charge for a randomly selected student, then T is equal to 50 times X, 50 times the number of credits. So what is the shape? What is the mean? And calculate the standard deviation. So here's the original probability distribution. The shape is going to be the same. It's roughly symmetric and has 3 peaks. Then the center will be multiplied by 50, and the variability would also be multiplied by 50. So the rules that we learned back in chapter 2 about transforming the data are the exact same as transforming a random variable.